So the first one here is the internal energy. So the internal energy of a system is simply the amount of energy contained in that system. And yeah, we can obtain this directly from the first law of thermodynamics. If you recall the first law of thermodynamics, it tells us that the heat change of a system is its change in internal energy plus the work done against external forces. So we can obtain delta U directly from here, the internal energy, as delta Q minus delta W. Okay, and delta Q, actually, we can get the expression of delta Q in terms of the entropy. That's delta U equals, that's T ds. So T, let me say T delta S, since I'm using delta. So T delta S is the expression of delta Q, and then the work done is just the pressure times the change in volume. Okay, so this is the expression of the internal energy. So usually, we can write it in differential form as du equals T ds minus B dV. So this is the expression of the internal energy, and it's the first thermodynamic potential, which gives us the internal the energy content of any thermodynamic system. Okay, so the second thermodynamic potential here is the Helmholtz free energy, which is usually denoted by capital F. So the Helmholtz free energy is the energy available in the system to do work at constant temperature and volume. So it's given by F equals U minus Ts, and we can obtain the differential form of this by just differentiating this expression. So dF is equal to du minus, we differentiate this using the product rule, so that's Tds minus Sdt. And then we can replace the expression of du by this. That's going to be Tds minus B dV minus Tds minus Sdt. And if we simplify this, because this can cancel with this, so we are left with negative Sdt minus B dV. Okay, so we can write dF as negative Sdt minus B dV. And this is the expression of Helmholtz free energy, which reflects the energy available in the system to do work at constant temperature and volume. And then if you want the differential expression, then you can see that we have dF as a function of any temperature change dt and any volume change dV. So the variables really that come into play here are, we can say that F is just a function of T and V, okay, or dF if you prefer. All right, so let's move to the third thermodynamic quantity,